Hey everybody, this is Mr. Beckstrom. I'm going over the problem today from school. I actually solved it about 5 minutes after you guys left. It was a lot easier than I thought it was. I think I was just getting confused with everything that was being done. But let's go through it, and I'll start from the beginning here. So, again, we have right? We have an isosceles right triangle. Um, we'll call this side L. We'll call this side L for length, and we'll call this side the hypotenuse. Now, notice that we have a relationship. We have a relationship between our hypotenuse and our side length. So let's work that out again real quick. So L squared, basically one leg squared plus another leg squared, that's going to be equal to the hypotenuse squared. And if we solve that, that's going to give us the hypotenuse is equal to the square root of 2L squared, which is equal to, we can break that up into two radicals, square root of 2 times the square root of L squared. And that'll just give us, since L is a positive value, because we're talking about distance or length, then that's just going to give us L times the square root of 2. Okay, so let's put that over there. So height is equal to L times the square root of 2. And we also know that the increase in length, so that's going to be the derivative of the length with respect to the area, right triangle, I'm sorry, with respect to time, is going to equal 2. And we'll use that in our stuff that we're doing here as well. So the first question says, at what rate is the area of the triangle changing when the legs are 2 meters long? So we need to associate area with the length of the legs. And we did this in class, but area is equal to basically 1/2 the length times the width. So that's going to be 1/2. And in this case, both the length and the width are L. And just remember that when we're determining the base and the height of a triangle, those two distances have to be perpendicular to each other. So this is going to be 1/2 L squared. And now, remember, we're looking for the rate of change of the area with respect to time. And we know the rate of change of the, let me make that a little bit better for now. We know the rate of change of the length of the legs with respect to time. So at this point, we can just take the derivative. It's just like implicit differentiation, and we're going to do this with respect to time. So the derivative of a is just 1, but we also have to multiply by dA over dt, because we just took the derivative of a variable other than t, which is almost always going to be the case in these types of problems. And then this is going to be 1/2 times, and then we're going to use the power rule for this. So this will be, bring the 2 out front, and then reduce the exponent by 1. And then this is going to be times the rate of change of the length of the leg with respect to time. So let's clean this up just a little bit here and see what we get. All right, so this is going to be the derivative of the area with respect to time is equal to 1/2 times 2 is just 1. So this is the length times dl over dt. dl over dt. Now, This is what we want, so that's already isolated, so we're good on that. And then as far as the length, it's in the question. It says the length of the leg is 2 meters long, so we replace the length with 2, and the rate of change is also 2. So this is just going to be 2 times 2, which is equal to 4. So in this case, this is going to be 2, that's the length of the leg, times 2, which is the rate of change of the length of the leg, and that's just going to be equal to 4. So that's the answer to part A. All right, now let's take a look at B. B says, at what rate is the area of the triangle changing when the hypotenuse is 1 meter long? So for this part, we're going to have to solve for L in terms of H. So luckily we have a nice little relation here that H is equal to the square root of 2 times L. So let's use that down here. So this is part B. So H is equal to the square root of 2 times L. And if I solve for L, this means that L is equal to the hypotenuse divided by the square root of 2. And it says the hypotenuse is 1. So this is going to be equal to 1 over the square root of 2. So all we can do, or all we have to do now, is just go back to our original equation and substitute the L with 1 over root 2. So that's just going to give us, oops, move that by accident there, this right here. So it's going to be equal to, oh, kind of moving all over the place here. So remember, again, we are asking for the change of rate of the area. So that is going to be dA over dt. Again, that is just going to be L times the derivative of L with respect to t. So L times the derivative of L with respect to t. Again, L is equal to 1 over root 2, and dL over dt is just equal to 2. So we get root, or 2 over root 2, which if we multiply the top and the bottom by root 2, excuse my horrible 2, we're going to get 2 root 2 all over 2. Again, I just multiplied the top and the bottom by the square root of 2. Those cancel out, and finally I just get the square root of 2. Alright, so not too bad, and let's look at the last part of this. It says, at what rate is the length of the hypotenuse changing? And this is kind of where we tried a few different things, and we're getting a little hung up there. So all I need to do is find a relationship between the length of the legs and the length of the hypotenuse. And I have it right here. So that's all I need. H is equal to L times the square root of 2. So I hate this new whiteboard, by the way. So H is equal to part C. So H is equal to L times the square root of 2. Now at this point, if I just differentiate both sides with respect to t, I'm going to get the derivative of h with respect to t is equal to, the square root of 2 is just going to drop off, or the L is just going to drop off, just leaving me the square root of 2 times the derivative of L with respect to t, right? Because the derivative of any number times a variable is just that number. That's that part. And then since we took the derivative of something other than t, then we need to add the dl over dt here. Now we already know that the dl over dt is equal to 2 from the initial part. of the question. So this is just equal to 2 times the square root of 2. And we are finished. If you have any questions, please let me know, and I hope you have a great rest of your day. Thanks.